So this question relies on your ability to represent two-digit positive integers with the place value setup. So t here is the tens digit, and u is the units digit, which means the value of that number is 10 times the tens digit plus u. So that's what n is numerically equal to. What they tell us that it has a property that if you were to reverse the order of the digits, meaning you turn this into ut, meaning going from, say, 37 to 73, this new number would have a value of 10u plus t. What they're saying is if you add these two numbers, then the result is a perfect square. So that's the condition. So let's see what happens here. Well, that simplifies algebraically to 11t plus 11u. If I factor out an 11, it's 11 times t plus u, and we're told that this is a perfect square. What that means is this is some number squared. So we already have 11, which is prime, and then you'll notice t plus u is going to fall between, because t can take values from actually not 0, because it has to be from 1 through 9, and units digit can again go from 1 through 9, and their sum has to fall between 2 and 18, and you'll notice that the only way this would be a perfect square is that if t plus u is 11, because in no other condition, because this would then mean it's equal to 11 square or 121. For example, it's 7. This is not a perfect square. Any other number is not going to work because 11 itself is prime. So this is the condition that the sum of the tens and the units digit has to equal 11. So we can come up with those numbers. The smallest would be 2 and 9, and of course the reverse of that works too. So 29 is a possibility, 92. In both cases, 29 plus 92, if you add them, it's 121. If it's 92, then you're adding its reverse. So you have to take into account both of them because these two are distinct numbers. And then we go to the next higher value. For t, 3, 38, 83. Note here, I'm looking for where the digits add up to 11. And then 47, 74, 56, 65, and then after that, if you go to 7, you go back here. So that's it. So we have a total of 8 such values for n, and the answer is E.